Have you ever gazed upon the night sky and wondered about the mysteries it holds? The universe is a vast, enigmatic space that is still largely unexplored. Its infinite expanse, filled with countless galaxies, stars, and celestial bodies, is a testament to the profound mysteries it harbors. Our fascination with this grand cosmic theater has led us to seek understanding, to yearn for knowledge beyond our terrestrial confines. This curiosity has driven the human race to venture into the unknown, to unravel the cosmic tapestry threaded with galaxies, stars, and the dark matter that binds them. To aid in this quest, we've developed tools of exploration, the most prominent among them being telescopes. These cosmic binoculars allow us to pierce the veil of darkness, to gaze upon distant celestial bodies, and to grapple with the enigmas of the cosmos. To delve deeper into these cosmic secrets, we now have a new tool at our disposal: the Euclid telescope. The Euclid telescope, a marvel of modern technology, is Europe's new eye in the sky. This extraordinary piece of equipment is the latest addition to the fleet of space telescopes launched by the European Space Agency, or ESA for short. Named after the ancient Greek mathematician Euclid, known as the father of geometry, this telescope is designed with a mission that's as grand and complex as the geometric principles its namesake introduced. The development and launch of the Euclid telescope are milestones in our never-ending quest to understand the universe. This journey began not too long ago when a team of brilliant minds pooled their collective genius to design and construct this state-of-the-art observatory. With a launch weight heavier than a full-grown African elephant and a height taller than a two-story building, the Euclid certainly makes for an imposing figure. After the successful launch, the Euclid embarked on its journey to the L2 point, a stable spot in space situated a staggering 1.5 million kilometers from Earth. The telescope's first task was to capture and send back stunning photographs of our universe. And oh boy, did it deliver. The telescope's cameras, powered by almost 600 million pixels, allowed us to see even well-known regions of the sky in an unprecedented level of detail. The first images showcased a stunning panorama of over 100,000 distant galaxies and the striking Horsehead Nebula, a breathtaking spectacle that resembles our very own Milky Way. But the Euclid's work is not just about capturing pretty pictures. It's set to delve into the heart of one of the biggest mysteries of our cosmos, the dark, unseen forces that influence the universe. By mapping the forms, positions, and motions of billions of galaxies up to 10 billion light-years away, the Euclid will help us understand the nature of dark matter and dark energy. The Euclid telescope isn't just about capturing breathtaking images. Its mission runs much deeper. Euclid's mission is not just to explore, but also to map the universe in a way that's never been done before. Imagine the universe as a vast, uncharted ocean, and Euclid as the explorer tasked with mapping its depths. But instead of an ocean, we're talking about the cosmos, and instead of a simple map, we're aiming for a three-dimensional representation of it. Euclid is embarking on a cosmic cartography project of epic proportions. The goal? To create the largest ever three-dimensional map of the universe. This is not just about pinpointing the locations of stars and galaxies. It's about understanding their forms, their positions, and their motions. It's about studying the cosmic ballet of billions of galaxies, some of which are up to 10 billion light-years away from us. Now, you might be wondering, why is this important? Well, galaxies are not just pretty cosmic ornaments. They are the building blocks of the universe. Understanding their distribution and movement helps us uncover the fundamental properties of our universe. We're not just talking about the matter we can see either. This mission will also shed light on the dark, unseen forces influencing the cosmos. Dark matter and dark energy remain some of the biggest mysteries in modern cosmology. While we can't see them directly, we can detect their influence through their gravitational effects on the visible universe. Euclid's detailed map will help scientists unravel these cosmic enigmas. Imagine standing on the edge of a cliff, looking out at an ocean. Now imagine that ocean is the universe, and you've got a telescope that can not only see the distant shores, but also the currents flowing beneath the surface. That's what Euclid offers. An opportunity to not just see the universe, but to understand the currents that shape it. Euclid's mission is a monumental task. It's akin to trying to hear a whisper in a thunderstorm or seeing a candle flicker in broad daylight. But if anyone can do it, it's Euclid. With this telescope, we're not just observing the universe, we're understanding it. With this mission, we're not just observing the universe, we're understanding it. The Euclid telescope is more than just a telescope, it's a window into the unknown. Just think about that for a moment. This isn't just about capturing pretty pictures of distant galaxies, though it does that with aplomb. No, this is about something far grander. The Euclid telescope is about understanding our universe in an unprecedented way, about peeling back the layers of mystery that shroud the cosmos. With its detailed images and data, the Euclid telescope is providing scientists with the tools to delve into these mysteries. Its capabilities allow us to observe the forms, positions, and motions of billions of galaxies, some of which are as far as 10 billion light-years away. That's a distance so vast, it's almost unimaginable. But with Euclid, we can reach out and touch these far-flung corners of the universe. And it's not just about what we can see, it's also about what we can't. Dark matter, dark energy, these unseen forces that influence the cosmos, they're some of the biggest mysteries in science today, and yet they make up the majority of our universe. With Euclid's help, we might just be able to shed some light on these dark corners of the cosmos. Imagine being able to understand the very fabric of our universe, to grasp the forces that shape galaxies, that dictate the birth and death of stars, that govern the vast cosmic ballet we're all a part of. That's the potential impact of the Euclid telescope. But the true beauty of this telescope isn't just in its scientific achievements, it's in the way it changes our perspective. It reminds us of our place in the universe, of the grandeur and majesty of the cosmos. It's a humbling and awe-inspiring realization. The Euclid telescope is not just changing the way we look at the universe, it's changing the way we understand it. And in doing so, it's taking us one step closer to answering some of the most profound questions about our existence. Have you ever pondered the impact of a man from over 2,000 years ago on our modern perspective? Fasten your seatbelts as we embark on a thrilling journey into the life of Euclid, the father geometry. In the annals of ancient history, few minds shine as brightly as that of Euclid. This Greek mathematician, logician, and geometer who lived around 300 years before Christ fundamentally changed the course of mathematical thought. Yet the man himself remains somewhat of an enigma. Most of what we know about him comes not from his own writings, but from those of later philosophers like Proclus and Pappus. Euclid spent much of his time in Alexandria, one of the intellectual hotspots of the ancient world. There he likely rubbed shoulders with other great minds of his. Some speculate that he even studied at the prestigious Platonic Academy in Athens before his time in Alexandria. So, who was this man that bridged the gap between the ancient Athens Platonic tradition and the later Alexandrian tradition? Let's dive deeper into his work to find out. Euclid's masterpiece, The Elements, wasn't just a book, it was a revolution in thought. This cornerstone of geometric theory didn't just pop out of the ether. No, sir. It was the result of a meticulous synthesis of ideas from earlier Greek mathematicians like Hippocrates of Chios, Eudoxus of Cnidus, and Theaetetus. The Elements was a game-changer, laying the groundwork for the field of geometry. Its impact was so profound that it continued to dominate the discipline until the early 19th century. That's like having a bestseller for over 2,000 years. The brilliance of Euclid's approach, now known as Euclidean geometry, was in the way it combined fresh insights with established ideas. This wasn't just a book of theorems, it was a masterclass in mathematical logic and reasoning, drawing from a limited set of assumptions to derive groundbreaking conclusions. Euclid's Elements was not just a book, but a beacon of knowledge that illuminated the path for future mathematicians. Euclid's influence didn't stop with geometry. Yes, indeed, the father of geometry had his fingers in many mathematical pies. Delving into number theory, he explored the properties and relationships of numbers in a way that had never been done before. He also dabbled in spherical geometry, a field that studies figures on the surface of a sphere, and introduced mathematical rigor, setting an unshakable foundation for logical reasoning in mathematics. And let's not forget his work on perspective and conic sections, where he provided valuable insights into the intersection of planes and cones. Euclid also authored lesser-known works like Data and Phenomena, which, although not as famous as The Elements, still showcased his intellectual prowess. Moreover, he made significant contributions to optics, an area that studies light and its behavior. His work in this field was so groundbreaking that it set the stage for future scientists and mathematicians to explore. From geometry to optics, Euclid's mathematical prowess was truly unparalleled. Even after 2 millennia, Euclid's influence is undiminished. The genius of this ancient mathematician resonates in the modern world, with his principles forming the backbone of many mathematical and scientific concepts we use today. Euclidean geometry, his brainchild, is the secret sauce behind the architectural marvels that dot our cityscapes. From the humblest house to the most towering skyscraper, the principles of Euclid guide their design. His influence goes beyond the realm of architecture. The field of optics, crucial to the workings of cameras, microscopes, and even your eyeglasses, owes a significant debt to Euclid. And let's not forget the GPS systems that guide us on our journeys. These too are rooted in the principles laid out by Euclid. Euclid's legacy is not confined to dusty old textbooks. It's alive and thriving in our everyday lives. So, the next time you marvel at a skyscraper or use your GPS, remember Euclid, the man whose genius continues to shape our world. Isn't it intriguing to ponder over the secrets the universe is concealing from us? Ah, the universe, an infinite expanse of glittering galaxies, nebulae, and celestial bodies, each holding its own mystery. There's a particularly enigmatic part of the cosmos, the dark universe, elusive and largely unknown. It's like a cosmic shadow dancing just out of our grasp. We've made strides to understand it, but the more we learn, the more questions arise. To unravel these mysteries, let me introduce you to a special explorer, the Euclid satellite. Launched on July 1st, 2023 from Cape Canaveral, Florida, the Euclid satellite embarked on an ambitious journey. With a mission to delve deep into the mysteries of the dark universe, Euclid set its sights on the distant cosmos. Aided by its powerful eyes, it plans to survey billions of galaxies, spanning over a third of the sky and reaching back to 10 billion light-years. This isn't just a sightseeing tour, though. The satellite is on a quest to chart the large-scale structure of the universe across space and time. It's like drawing a detailed map of cosmic history. Euclid will probe the universe's structure formation, its expansion, and will delve into the enigmatic realms of dark matter and dark energy. It will also seek to understand gravity's role in the grand cosmic play. This is no small task, and the stakes are high. With this mission, Euclid satellite is set to bring us closer to understanding the hidden secrets of our universe. Now, you might be wondering how the Euclid satellite is equipped to undertake such a mammoth task. Well, let's delve into the heart of this celestial marvel. The Euclid satellite houses two state-of-the-art scientific devices specifically designed to analyze the light from distant galaxies. At the core of these devices is a mirror telescope with a diameter of 1.2 meters. This isn't just any mirror, it's a cosmic light collector, pulling in the faint whispers of galaxies billions of light years away. But the magic doesn't stop there. The telescope has a unique dichroic filter. Now, this isn't a filter you'd find on your latest smartphone camera. This filter is a game changer. It separates the collected light into visible and infrared spectrums. This separation is crucial, you see, because it allows for detailed analysis of the light in its different forms. This light, now split into its individual spectrums, is received by two instruments: the near-infrared spectrometer and photometer, or NISP for short, and the visible instrument, also known as VIS. These instruments are like the satellite's eyes, capturing and studying the light to help us understand the mysteries of our universe. With these advanced tools, the Euclid satellite is not just a piece of technology in space, but our eye into the unknown, set to reveal the secrets of the dark universe. If you want to keep up to date and get notified when we release new videos, click on like and subscribe. This helps us keep the channel going and lets us know that you're enjoying our content. Have you ever wondered how we know so much about galaxies far, far away? It's a question that often stumps even the brightest minds. The cosmos, with its myriad of galaxies, has always been a source of awe and wonder. It's like a grand cosmic jigsaw puzzle, waiting to be pieced together. And you know what helps us decode this gigantic enigma? It's a remarkable tool, a cosmic detective, if you will. Well, the secret behind our cosmic knowledge is none other than the visible instrument, or VS for short. The visible instrument, a marvel of human innovation, has a fascinating tale to tell. Born from the insatiable curiosity of mankind, VS is a testament to our thirst for understanding the cosmos. With its unique ability to capture detailed photos of galaxies, VIS is changing the way we perceive the universe. This astronomical powerhouse operates in the visible light spectrum, hence the name VIS. Its sensitivity range stretches from 550 nanometers for green to 900 nanometers for near-infrared, allowing it to capture the universe in all its colorful glory. The device is a mosaic of 36 charge-coupled devices, each packed with over 16 million pixels. This gives VIS a staggering total of around 600 megapixels, equivalent to more than 74K resolution panels. But it's not just about the high-resolution images. VIS has the ability to measure the forms of over 1 billion galaxies. Now that's a billion with a B, folks. It's all because gravity, that same force that keeps your boots on the ground, also affects the forms of galaxies. VIS, with its precise distance measurements, allows scientists to map out the three-dimensional distribution of matter in the universe. And what's more, this incredible instrument is helping us investigate how cosmic acceleration alters the expansion history of the universe. Indeed, with VIS, the universe isn't so much of a mystery anymore. Now, how does this fantastic VIS work, you ask? Well, as the name suggests, VIS is a master of capturing visible light, with a sensitivity range from 550 nanometers for green to 900 nanometers for near-infrared. It's like a chameleon adapting to the different light wavelengths around it. The heart of VIS is a mosaic of 36 charge-coupled devices, or CCDs for short. Each CCD is a photosensor packed with over 4,000 pixels by 4,000 pixels. That's a lot of pixels. In total, this gives the detector a whopping 600 megapixels, equivalent to over 74K resolution panels. One of VIS's most impressive features is its wide field of vision. Imagine the area of 2.5 full moons as seen from Earth. That's what VIS can cover in one go, and with its ability to gather light for extended periods, VIS offers the finest low-light sensitivity ever achieved over such a wide range of wavelengths. With VIS, we've got the universe in our sights quite literally. So what does all of this mean for us and our understanding of the universe? Well, the visible instrument, or VIS for short, is revolutionizing the way we gaze at the cosmos. This mighty tool captures images of galaxies far more detailed and across a greater expanse of sky than ever before possible. Imagine over 1 billion galaxies, their forms delicately influenced by gravity's pull on light, all measured and mapped out in three-dimensional detail. What's more, VIS isn't just about visible light. It's also finely tuned to the near-infrared spectrum, making it a versatile observer of the universe. With its wide field of vision, equivalent to 2.5 full moons, and its exceptional low-light sensitivity, VIS is able to gather light for an extended period, providing us with the most comprehensive view of space. In the grand scheme of things, VIS is our window to the universe, bringing the cosmos closer to us one galaxy at a time. How we measure the light a galaxy emits at each wavelength is truly fascinating. Get ready to have your mind expanded. You see, there's this nifty process called spectroscopic measurement. It's like the universe's own unique light show, and it's how we figure out how much light a galaxy emits at each wavelength. Now, why is this important? Well, it helps cosmologists, those are the folks who study the universe, to understand how far apart each galaxy is from the others. Enter the Near-Infrared Spectrometer and Photometer, or NISP for short. This little gadget is a game changer. It focuses on spectroscopic measurements, enabling us to transform Euclid's data into the most comprehensive and precise three-dimensional survey of the universe ever undertaken. Spectroscopic measurements are like the universe's own unique fingerprint, and NISP is the detective deciphering the clues. Now, you may be wondering, how does NISP do this? The answer lies in something called redshift. You see, redshift is a key concept in cosmology. It's like the Doppler effect, but for light. When a galaxy is moving away from us, its light waves stretch out, appearing more red than they actually are. This shift towards the red end of the spectrum is what we call redshift. By measuring the redshift of different galaxies, we can calculate their distances from us. The greater the redshift, the farther away the galaxy is. This is how NISP helps us map out the universe in 3 dimensions. But that's not all. This redshift information also allows us to study the distribution and temporal evolution of galaxies. This, in turn, provides insights into dark energy, which influences the universe's expansion, and dark matter, which impacts gravity. Redshifts are our cosmic measuring sticks, and with NISP, we can use them like never before. NISP isn't just any infrared sensor, it's the widest field of vision for an infrared sensor ever flown in space. What sets NISP apart is its phenomenal grid of 16 detectors. Each one of these detectors is packed with over 4 million pixels. That's 2040 by 2040 pixels to be precise. They're the workhorses, measuring near-infrared light from 900 to 2000 nanometers. Now, imagine the light entering the detector. It's like a guest walking into a party. The host, either a spectrometry grism or a photometry filter, directs it where to go. These hosts are selective, each one allowing only specific guests to pass through. The Y, J, and H bands are the VIPs, the specific wavelength ranges of light that get the nod. And the grism? It's more than just a bouncer. This grating prism scatters light, measuring the intensity of each wavelength. With NISP, we're not just looking at the stars, we're analyzing them in unprecedented detail. But why do we need to know all this? Why does it matter? Well, it's not just about exploring the universe, it's about understanding it. You see, these measurements we've been talking about, they give us insights into two of the most mysterious aspects of our universe: dark energy and dark matter. Dark energy, it's a strange force that's causing our universe to expand at an accelerating rate. It's like the universe is a balloon, and dark energy is the helium pumping it up. Now, the distribution and temporal evolution of galaxies we measure, they help us understand this enigmatic force. Then there's dark matter. Despite being invisible, it's the glue holding galaxies together. Its impact on gravity is critical for the formation and evolution of galaxies. By studying the light from galaxies, we can indirectly observe the effects of this invisible matter. Through spectroscopic measurements and NISP, we're not just exploring the universe, we're unlocking its deepest secrets. These are just some of the striking images of the universe that Euclid has captured so far. Spiral galaxy IC 342. First image is the dazzling edge of darkness. The Horsehead Nebula at zoom level 2. The Horsehead Nebula at zoom level 1. Wide-eyed look at the cosmos with the moon. Loopy star trails show the effect of Euclid's fine guidance sensor intermittently losing its guide stars. View of IC 342 at zoom level 1. Early commissioning test image NISP instrument grism mode. Dive into the marvel of the cosmos, delighting in its vast beauty. As astronomy advances, we're gaining a universe's viewpoint, deciphering our unique place within its infinite expanse. If you want to keep up to date and get notified when we release new videos, click on like and subscribe. This helps us keep the channel going and lets us know that you're enjoying our content. Ever marveled at the cosmos through the eyes of Euclid, ESA's very own satellite? Its shots, crisper than a morning frost on a pumpkin, reveal the universe's best-kept secrets. But friends, what celestial marvel should Euclid capture next? The twinkling vestiges of a supernova or the elusive dark matter? We're all ears, or rather eyes, for your suggestions. Drop your cosmic wishes in the comments. But remember, these photos are bigger than a Texas rodeo, so brace for some hefty downloads.